what you are basically assuming that you're seeing, right? So you're assuming that like you're actually seeing, this is, I found some Korean website, I don't know who made this, but whoever it was like did it very well. So what you're assuming, right, is that the dress is really kind of like this, right? It's kind of like blue and black, and that what you're seeing is a blue-black dress illuminated with a lot of kind of yellowish bright light, right? So that like, you know, what you're actually seeing with your eyeballs is basically something like this, where the illumination has kind of made all the wavelengths more yellow than they would normally be under neutral lighting. But your assumption is, you know, that your brain kind of subtracts out that yellow background, and it leaves you with the inference that you're seeing blue and black. Now, if you are a gold and white person, you're essentially assuming the opposite thing, right? That the dress is in fact gold and white, but that the illumination is kind of on the bluer side, and so your brain makes this inference that like, well, because the illumination is kind of bluish, you subtract out that background effect, and that leaves you with the impression that you're seeing a gold and white dress, right? And I don't know if this, if you believe this or not, but in fact, the dresses like here and here are totally identical to each other, right? So like you can see both of these examples on this slide, like what your brain is inferring, but in fact, like both of these are in fact the same pixels. And I think, yeah, the next slide kind of has that, right? So if you kind of take a chunk out of the left image and move it over into the right image, you see like no funny business going on, right? But if you kind of just move it into this area where the lighting is assumed to be, you know, bluish rather than yellowish, you can see that that it changes your person, right? So like again, it's not super clear like why some people's brains default to like the yellow light interpretation and why some people's brains default to the blue light. That must just be that the image is taken in a funky way such that like it kind of, people have like small differences in their color perception and that happens to catch that. But you can see why like the same like pattern of pixels could lead to both the blue-black or the yellow-gold experience, right? Okay. Okay. So one thing I should mention, I guess, is like tying this back to like the themes of the class, right? So one of the things we've talked about, we will talk about over and over again. If you remember when we talked about decision demons and like avoiding accidents and stuff, and we were talking about middle vision, right? One of the things this illustrates, right, is that like, you know, a plausible interpretation your brain could come away with, and this is kind of what my brain comes away with because I've studied this image so long. Your brain could come away with like an interpretation that this is neither blue and black nor yellow and gold, but like it's kind of like blackish gold and bluish white or something like that, right? But usually we don't come up with that in-between interpretation, right? And that's a good example, I think, of your brain kind of saying like, well, I can imagine a blue-black dress that would look like this, or I can imagine a yellow-gold dress that looks like this, and it doesn't kind of like split the difference, right? You kind of decide one or the other, right? And that's a good example of your visual system like trying to not, like it avoids accidents, right? It assumes this is not some great coincidence, even though it kind of is. And it tries to pick the most likely interpretation rather than kind of like splitting the difference between two possible interpretations. And it just so happens that like, you know, our different brains kind of make different judgment calls, right? But it kind of shows this thing about how your brain tries to make a plausible interpretation of the world, even when the information is actually kind of ambiguous. Okay, so questions about that before we jump to the last little chunk here. Everybody okay so far? Okay, feel free to speak up if you have it. Okay, so we have a little bit left to talk about in color. We actually might not quite get to all of it today, but we'll come close. This is what I call just kind of the grab bag chunk of color stuff because I didn't have like a great system of organization for all of it. This is kind of a neat thing. So we haven't actually talked too much in this class about adaptation effects, although I did just kind of foreshadow them a little bit. So while I'm talking through this idea, I will let you kind of do this demo. So what you should do while I'm talking to you is if you see this little like plus in the center of this image, just focus your eyes on that plus and try not to move them around any, right? Keep your eyes right on that black plus sign for the next minute or two while I'm talking to you. So we haven't talked about adaptation effects too much in this class yet, but you've probably all done some kind of adaptation thing before where you like basically, you know, stare at the same thing for a long time and you get your eyes kind of used to that. And then don't do this yet, but then if you were to like shift your eyes over to like a blank wall or something like that, you kind of see the opposite impression of what your eyes had kind of gotten adapted to, right? So The idea here, and that's kind of similar to the idea I was just talking about, like keeping your hands in hot and cold water, right? Is that like when your hand gets used to cold water, you know, its ability to sense cold kind of like tires out. And then when you put your hand in neutral water, it's sensitive to that contrast, right? And it actually feels like the neutral water is hot. Okay, so keep your eyes in the exact same position. I'm just going to switch this image over as we keep talking about this. But keep your eyes in the same exact position. Try not to move them. There we go. All right. Now, hopefully, if this worked, it'll probably go away after a second or two. Did you guys have the impression that this was like you were looking at a color photograph for a couple of seconds here? All right, I'll do another version of this while we kind of talk about why this works. All right, so here's a chameleon again. Same basic idea. There's a little fixation point in the center. You can get your eyes fixed on that. So, you know, the general idea of adaptation you're probably somewhat familiar with, right? Which is basically like your nervous system can get used to certain things, right? And that basically, you know, when you get used to cold, you go into like a room temperature, you know, like in the wintertime, you're walking around in the cold outside for, you know, 20 minutes. You know, we probably all had the experience where you get kind of like almost frostbitten in your hands. Then you come in and run your hands under like, under kind of like room temperature water or something, right? And it feels like your hand is on fire. Because basically you have numbed your fingers to the ability to sense cold. So all they really sense in that you know, room temperature water is the heat of it. And it feels like it's super, super hot, even though you know that is not true, that it's actually room temperature, right? So the same thing is going on in the visual system here, right, with color. So you're getting adapted to these colors, and now if I switch the scene over, all right, you're going to get that kind of color photo impression for a second, hopefully. All right, so we'll do this one more time while I kind of finish up this concept. So the key thing here, right, is we've probably all, this is kind of the classic one that is like built in for this demo. So you can focus your eyes right there. So we've all probably done this thing, right? I know I've seen versions of this where you like adapt your eyes to like an inverted American flag, and then you like, you know, shift your eyes over to a neutral background, and you know, you see like, you know, kind of the actual American flag or whatever. The kind of weird different thing about this demo, right, is that you can tell while you're looking at this image. I mean, first of all, you can kind of tell what you're looking at, right? You can tell that these are like rabbits, but you know, you can tell also that this is kind of a blurry or like blocky image, right? There's not a lot of detail in this image that you're adapting to. But I think the weird thing about this demo, right, what this is, you don't have to know this, but it's called the Sadowski effect, or I think that's the name of the guy who first demonstrated this. The weird thing about the Sadowski effect is if you can keep your eyes, you know, fixed right on that fixation point as you're adapted, and keep them there as we switch over to the next slide. Ta-da! Right. So the weird thing about the Sadowski effect, if it works for you, is that when we first switch over to this purely black and white image, or this grayscale image, that has no color information at all, but it is no longer blurry, right? It now has like all the line detail information. The weird thing about it, right, is that you don't perceive, what you don't perceive, hopefully, is a mixture of like a sharp black and white image with a kind of blurry color image, right? Your visual system kind of fuses that blurry color information that you have adapted to with the sharp detail information that is actually visibly present, right? Do people get that experience when you look at this? Like that it looks like a real sharp color photograph for a few seconds? So the key idea here, right, is this gives you a hint, and this is actually, you know, more or less true, of how your visual system kind of integrates or processes color information alongside like luminance information, right? So we've kind of talked about like lines and edges and how you resolve objects and so forth first, and then now we've talked a little bit about color and how we sense color. But the fact is that like you actually do process these things pretty much separately, right? So your sort of achromatic system that processes all the edges and so on and so forth and figures out kind of what shape stuff is, that's kind of one separate system. And then your color system is kind of separate from that, right? And it clearly gets integrated at a certain point because, you know, you perceive things as just like objects with color. You don't perceive them as like black and white objects and then also like splotches of color. But what you can kind of tell from this, right, is that like the color information is kind of kept in this separate place than the line information, right? And that your visual system just kind of fuses those together somehow using the kind of like achromatic system to kind of tell you what the shape of things are, and then the color system kind of like fills that in, right? But you don't need like as spatially precise color information because your visual system kind of automatically like binds together the general color of things and kind of makes it conform to the lines that you're analyzing with your achromatic system. So I mean, it's a little tricky to like describe this because as far as I know, we don't know exactly how this works in the nervous system. We're not going to talk about it much more than this, but it's kind of neat, right? And it kind of shows you how like this color and sort of line or detail information can be kept separate and only fused at kind of the last moment at which you kind of perceive the whole thing. Okay, does that make sense? Any questions about that idea so far before we go on?